Hello, my name is Ilker Baz. I'm a research scientist at Virginia Transportation Research Council, research division of Virginia Department of Transportation. In this presentation, I'm going to cover a test method that evaluates the rutting potential of asphalt mixtures. It's a simple and practical test and called ideal RT test. It's a test that is recently proposed, and we evaluated this test as part of our research study, still undergoing, and recommended for incorporation into V.BMD spec as an alternative to APA test. As for the IDT high temperature test, there is no standard available for this test yet. I believe there is a work undergoing right now to make this a ASTM standard. But as of now, we don't have any available test standard. But again, specimen procedure and testing procedure are the same with the IDT cracking test or IDT high temperature test. And we are going to see the details shortly. This test method covers procedures for preparing, testing, and measuring asphalt mixture rutting resistance, and also determination of shear strength to quantify rutting potential of asphalt mixtures under this test. This test method is intended to determine the rutting potential of asphalt mixtures. The index that you get out of this parameter, as I said, is the shear strength, and higher the shear strength, better the rutting resistance of asphalt mixture. As I indicated, this test will be incorporated into V.BMD specification as an alternative option for rutting evaluation. So you would have three different tests, rutting tests in the V.BMD spec: APA test, IDT high temperature test, and ideal RT test. You would have flexibility to choose from these tests to design your mix, evaluate your production, and then submit it to VDOT. The same apparatus that you use for IDT cracking test, IDT high temperature test is used for this test as well, except that the jig that you see that specimen is sitting on, it's a U-shaped support. It's available from manufacturer, several manufacturers. It's around $80, $100 or so. And then you would also need the conditioning environment that maintains that temperature at 54.4 C for this test. As for all other tests, two types of specimens are required: laboratory mixed and laboratory compacted for your mix design stage, field mix and laboratory compacted, that is for your production stage testing. Again, for this test, we are requiring 3 replicates as opposed to 4 replicates that you have in APA, and air weight content of 7% plus minus 0.5%, and a diameter of 150 millimeter and a height of 62 millimeter. Again, these are the dimensions that are used for cracking test. For specimen preparation procedure, for laboratory mix and laboratory compacted specimens, again, you would condition loose mix for 2 hours at the design compaction temperature prior to compaction. And then you would need 3 specimens compacted to this height of 62 millimeter and air void content of 7%, of course, with the diameter 150 millimeter or 6 inch. And then condition test specimens at 54.4 C for 2 hours. And again, this is the conditioning environment is already at that temperature, and then 2 hours start from when you place your specimens into that conditioning environment, and then start counting the 2 hours of conditioning from that point on. For field mix, you minimize any cooling of the loose mix, bring it to compaction temperature, and compact immediately to the air void and size requirements. Again, 2 hours of conditioning at 54.4 C. For testing, inspect the fixture for the cleanliness. Make sure that they are clean and free of debris, and install your specimens into the fixture. Make sure that it is centered and making uniform contact. One caveat in here is that if you don't have a portable loading frame as shown on the right hand side here on the picture, it will require you a little bit time to install the specimens, and that may jeopardize that 2 minutes of testing procedure that you would see soon here in the next slide. So you have to be careful about that. So again, loading rate is same as the cracking and IDT high temperature rate, 50 millimeter per minute. In this test, loading will not drop to 0.1. It will, because of the range, that LVDT range you have, and the displacement that is experienced with this testing at high temperature is larger than the displacement that you may get through IDT CT test or IDT high temperature test. So as long as that you reach the peak load and it drops, let's say 80% of the peak load, then you are fine to stop the test. Just like the TSR test, that once you exceed the peak load or reach the peak load, you could stop the test when you drop down to 80% of the peak load. And again, this is very important. Testing shall be completed in 2 minutes or less after removal of the test specimens from the conditioning environment. If you keep the specimens longer than that you will get false positive results on your cracking, on your rutting test here. The calculation for this strength is based on a peak load and a constant number that converted to shear strength. And note that the peak load has to be in kilonewton in this case. It's a simple, straightforward calculation in there. And then based on the research that we did, the minimum shear strength of 1.07 megapascal is needed for this test to satisfy rutting resistant mixture. For example, if you have a shear strength less than 1.07 megapascal, your mixture is susceptible to rutting in the field. On the other hand, if you have a shear strength of 1.07 and more, then you are passing the criteria and having a mix that is rut resistant. For this test, we don't have precision estimates and statements ready yet. Research is to be initiated soon to develop the precision estimates for this test as well. And with that, I conclude my presentation. Thank you for listening. Please email me any questions you might have at ilker.baz@v.virginia.gov.